This is our presentation on Bioswales by Jamie, Layton, and Yvette. Bioswales are designed to concentrate or remove debris and pollutants from stormwater runoff. They have swaled drainage with sloped or vertical sides and are filled with vegetation and potentially engineered soil mix. Bioswales can include multiple layers such as mulch, engineered bioswale mix, and a gravel base. Layers vary depending on design. Bioswales tend to be used for high volumes of runoff. This bioswale allows water to enter from multiple smaller openings at the sidewalk, which is higher than the street. The entry point is lower, as the street is also significantly lower than the sidewalk. At the downhill side, there is a drain which allows water to flow back onto the street if the bioswale is overwhelmed with excess stormwater.
Rain gardens complement the effectiveness of bioswales, but are intended for lesser volume of rainfall. Bioswales are usually deeper than rain gardens and allow water to flow with the grade while infiltrating through the layers. A bioswale and rain garden plan can be achieved by using soils that can easily slow down, infiltrate, and retain water. If the nutrients and water quality are a concern, soils and plants that can easily absorb high amounts of nutrients are recommended. Despite the obvious objectives, bioswales can be excellent ways of improving biodiversity and aesthetic appeal.
Vegetation in a bioswale is one of the most important aspects. Improving and maintaining the vegetation is essential, and it is recommended to avoid long-term inundation and erosive flow. This bioswale incorporates additional preliminary filtration in the form of a rock layer which the storm water must filter through before entering the bioswale itself. One opening serves as an outlet and another serves as an inlet. The backside also has an attractive tree guard. This bioswale is very deep-sided and is likely intended for high-volume rainfall.
There are three types of bioswales: wet swales, dry swales, and grass channels. Wet swales consist of sloped channels, vegetated sides, and slow water flows. The bottom of a wet swale is usually below water table. This helps encourage the growth of wetland vegetation. Maintenance is generally more strict than other types of swales. Wet swales are rarely used in residential areas due to standing water concerns. Dry swales are similar to grass channels but utilize engineered soil mixes and underdrains. Grass channels are the least technical type of bioswale and require the least input of resources. Maintenance is almost non-existent.
Native plants established in a bioswale can survive without any extra irrigation, which is very beneficial compared to other landscapes. Bioswale soil mix is a crucial part of most bioswales. Sand is often the component present in highest concentration, as it enables drainage and infiltration of runoff. Sand, however, does not aid in filtration of pollutants. Compost performs better higher up in the soil mix. At lower levels, it can create anaerobic conditions in the root zone and increase settling as it decomposes. It can also decrease porosity in high concentrations. Excessive levels of compost potentially risks adding nitrogen and phosphorus to runoff. Topsoil is used because of low cost and has good filtration but poor drainage.
This shows how a bioswale can accumulate fallen leaves during autumn. Removal of debris, garbage, and sediment is a regular occurrence, often taking place in spring and in fall. Maintenance requirements may vary according to design and location. As you can see from our presentation, local conditions and requirements dictate design and best practices management.